Hey, this is Mr. White.
Mr. Anderson.
Mr. Anderson's here. We're going to solve a bunch of these problems together, so let's just get started. We've got this trig equation. We've got sines and cosines, and that's not going to be easy. The first part of this question says to write it in this form. So what they're saying is that this equation can be written like this in some way or another. And then we're actually going to solve it. So, Mr. Anderson, what do you think?
Well, it looks to me like we got to deal with that sine squared somehow. So we probably want to look at that Pythagorean identity and substitute in.
Pythagorean identity. So that Pythagorean identity is going to be sine squared plus cosine squared equals 1, right?
Right.
So which one do we want? Do we want cosine squared equals 1 minus sine squared? Or do we want sine squared equals 1 minus cosine squared?
Well, we're going to have sine squared equals 1 minus cosine squared.
Sine squared equals 1 minus cosine squared. Why?
Yep. Well, now we can go ahead and substitute.
Yeah, but why? Why? I mean, what do you think? Like, for me, I see this cosine, and that doesn't really have any identities. So that's not going anywhere.
Right.
So, yeah, it does make sense that I'm going to take out sine squared, and I'm going to put in the 1 minus cosine squared. So let's do that. 1 minus cosine squared equals 1 plus cosine x. Okay? Now what?
Well, now we go ahead and distribute and
2
rearrange the equation.
minus 2 cosine 2x. So here's our distribution. We've distributed it plus this. And now we can start moving everything to one side. It's a positive 2, so let's just move everything over to the right. So we have, what is that, 2 cosine x squared plus cosine x, and then 2 minus 1 is minus 1. And they call this f of x. So good, there's part A. Part B says to actually solve. Alright. So what do you think, Mr. Anderson?
I think you factor first.
So 2 cosine x plus cosine x minus 1. Let's set it equal to 0. Set it equal to 0. So let's factor like Mr. Anderson says. And we get 2 cosine x. What else do we get?
Cosine x.
Cosine x. And options for this are pretty simple. 1 and 1. And I need a positive 1 cosine x. So this must be a plus, because I get a 2. This must be a minus, so it actually goes 2 minus 1. And let's just check, that's a minus 1. And I do get a minus 1 when I multiply those. Now what?
Well, set the factors equal to 0.
Set the factors equal to 0.
Isolate the cosine x.
Okay, so now we have cosine x equals 1/2, and we have cosine x equals minus 1. Let's just jump over to our graph. Here's cosine x from negative 2 pi to 3 pi. We're just going to use this graph to figure out how many solutions we're going to get. So we're going from 0 to 3 pi. So from 0 to 3 pi. First one says when cosine x equals 1/2. So let's just graph 1/2. How many solutions is that going to get?
Looks like 3 to me.
1, 2, 3. And let's go cosine x equals negative 1.
I'd have to see the domain again. Is it including 3 pi?
Yeah, there it is. Includes 3 pi.
Okay.
Closed bracket means it
So
includes.
we get 2.
So we get 2. Alright, so what are those 5 solutions for this? So let's draw a little mini unit circle here. The x value, the cosine, the x value equals positive 1/2. That happens right here. X equals pi over 3. Where else does that happen?
All the way around.
All the way around. We're going to go past pi. It's going to hit it again past, a little bit past 3 pi over 2. That's going to happen right here at was that 5
5.
pi over 3. And then it's going to happen one more time. It's basically this same one, but 2 pi later. So we're going to get pi over 3 plus 2 pi, which is the same thing as, what is that, 6 pi over 3? So the whole thing will be, am I right in saying that's 7 pi over 3?
Yeah.
Cool, there's 3. And then we can jump into this one really easy. When is cosine equal to -1? Well, that happens at pi, so x equals pi. And then it's going to happen again 2 pi later, which is going to be 3 pi. So there's your first solution.